Still assembling brake tubes manually? One-by-one alignment and insertion, missing and wrong installs are frequent. Inspection by eye. Any issue is a safety hazard. 3 pits of manual assembly. First, many brake tube models with different shapes. Workers grab the wrong part often. Second, insertion force purely by feel. Too much damages the O-ring. Too little leaves a loose connection. Third, incoming material scattered in bins. Manual sorting eats time. This line uses 3D vision plus a 6-axis robot, 22 seconds per brake tube. The 3D camera scans the scattered bin. Deep learning recognizes each tube's pose. The robot picks from random orientation. Force-controlled assembly inserts precisely. Zero human intervention. 3 core technologies. First, the 3D structured light camera generates point clouds. The deep learning algorithm segments each tube's pose. Stacked tubes are picked layer by layer. Second, a 6-axis force torque sensor monitors insertion force in real time. Compliant assembly between 20 and 50 newtons. The O-ring stays intact. Third, dual station alternating design. While Station A assembles, Station B picks and inspects, cycle locked at 22 seconds. Watch the demo. Brake tubes scattered in the bin. 3D camera scans and recognizes each tube's pose. Robot picks one precisely. Delivers to the inspection station for full surface and dimensional check. Qualified part sent to the assembly station. Force-controlled compliant insertion into the connector, fully automatic. By the numbers. Manual assembly averages 60 seconds per piece at 92% yield. Automated runs 22 seconds per piece at 99.5% yield. New model commissioning takes only 2 hours. Scan a 3D model. Configure a trajectory. No vision engineer required. This solution doesn't only assemble brake tubes, oil pipes, water pipes, AC tubes, and other flexible assembly tubing all fit. The 3D vision plus force-controlled assembly combination fundamentally solves 2 challenges: unordered material and precise insertion. The core of 3D vision assembly isn't how fast it recognizes. It's whether the deep learning model covers all your part models. Is your line's incoming material randomly scattered or neatly arranged?